This is the coffee detonator. I'm John Park for Adafruit Industries. So how the heck does this thing work? This is a blasting machine. It was used in mining operations to detonate TNT, and the way it works is that when you raise the handle and then give it a good push, you turn over a magneto, which is a type of generator. It generates between 30 and 60 volts of AC current at about 1.5 to 2 amps, but just for a moment. So it's not able to really power the coffee grinder. So the secret is I'm using an Arduino-compatible Adafruit feather that I've wired to receive the voltage signal in a way it can understand. It then flips the relay inside of this power strip, which then powers the coffee grinder off of the regular 120 volts that it's plugged into. In order to convert the AC current that's coming from the magneto inside of the blasting machine to a DC current that's much more microcontroller friendly, I'm going to use a really clever arrangement of 4 diodes that's called a full wave bridge rectifier. So I have the diodes plugged into a little breadboard here, and on 2 sides of the rectifier I've got an input that comes from the blaster, and then I have an output that's going to the multimeter. Multimeter is now in DC mode, so let's take a look at what kind of readings we get when I plunge the plunger. We're getting about 55 volts, and this is DC current, not AC. So the next job is to step the voltage down from the 30 to 50 or 60 range that we're getting right now to around 3 volts, which is the operating voltage of the Feather microcontroller I'm using. Now I've added a couple of resistors and a capacitor to the circuit, and these are going to act as a voltage divider to take the 30 to 60 volts that we're getting right now down to a more manageable 3 to 6 volts. The capacitor is going to act to smooth out any spikes in that voltage and give us a consistent read. 3 volts, that's perfect. That's exactly what we want to read using the analog input pin on our microcontroller. Now I've hooked up the Adafruit Feather microcontroller to my circuit. So I'm reading on analog pin 0 of the Feather the output of the circuit, which is already taking the AC from here at about 30 volts, converting it to about 30 volts DC, and then reducing that with the voltage divider down to up to about 3 volts. The Feather is reading those values at a range of 0 to 1023, and then those are being plotted on the serial plotter of the Arduino software. So right now it's reading close to 0, and you'll see the graph will modify its scale as I plunge the plunger. So now I'm getting anywhere from a 0 to 3 volt range read by the microcontroller, and what I want to do in software now is take that and have an if statement which says if the voltage is below a certain threshold, do nothing. But when it gets up to that 3 volt range, we're going to send a signal to a relay, and that relay is going to turn on the coffee grinder. What I'll do next is take this little circuit and solder a version of it onto a small proto board which will fit right on top of the Feather. Now I've got my circuit soldered onto this proto Feather wing, which will sit right on top of the Feather. I've got a couple of wires connected with terminal connectors, and these will screw into lugs in an enclosure which will then connect to these 2 lugs on the detonator. I've also got a couple of wires coming off which will be plugged into the smart power strip, and the 3 volt output on this wire is enough to control the relay inside of here, which will then allow 120 volts to flow through, controlling the coffee grinder. I can plug the proto Feather wing into this Feather M0, and I've got a LiPo battery connected to it, and I'm going to put it all inside of this little wooden enclosure. Now the enclosure has a couple of lugs I built using nuts and screws to connect to the little terminals, and then I can connect back to the blasting machine. And the USB port I've added here is going to allow me to send new software to the Feather if I want to, log things, and to also charge the battery. And I've left a little bit of space at the bottom for this wire coming out, and I have a little wooden lid that will slip onto here. In order to test this out, I'm going to connect the wiring from my blasting machine over to the microcontroller box, and I'm going to hook up an LED on the little output just to test things out and make sure that it's working before I connect it to this relay. I've set it up so that when this is plunged, the microcontroller is going to read that voltage and then send 3 volts down to this line for 5 seconds. Success. So now, instead of an LED, I'm going to control the relay inside of the smart outlet and then plug it into power. So this indicates that we have 120 available, and then we have a couple of normally off and a couple of normally on plugs. So what I'll do is plug my coffee grinder into the normally off, and then when the plunger goes, the microcontroller is going to flip those to on. All right, we're ready to go fully operational. So I'm plugging in the grinder to the normally off terminals in the power strip, and now give it a plunge. And there we go, we get 5 seconds of grinding. You can adjust that in software so that you get more or less, but with every new plunge, I get a little more coffee ground. I'm John Park for Adafruit Industries, and this is the Coffee Detonator.